Oh, this is 1.8 applications, like variation in percent and stuff like that. So, more word problem kind of thing, which, everyone loves. So when quantities, if it says it varies directly, I prefer to look at it more as a proportional, all right? Now, more specifically, proportional relationships or direct variations, it just means that as one value changes, another value will change proportionally, right? Um, well, let's see, I guess, if you work more, then you usually make more, right? And if you're getting paid by the hour, you do anyways. So the more you work, the more you get paid, or the less you work, the less you get paid, or it goes with lots of other things. Like the more you drive, or the longer you drive, the farther you go, usually, right? Or the less you drive, the less distance you go. But there is such a thing as an inverse variation as well, which just means that as one value changes, the other one changes in the opposite direction. So as one value goes up, the other goes down, or as one value goes down, the other goes up. Okay, that would be like the longer you drive, the less gas you have in the tank. See, as one goes up, the other one goes down. We'll look at those examples as we come to them, though. Now direct variation thing, I'm going to be using that, and it's not so common that people say, well, I'm going to set up a proportion like this, but this is really all a proportion is it's two fractions that are equal. So while these may look like negative symbols, they're really fraction lines, okay? And then I'm going to fill in these four spots right here. Right, we got this one here and this one, 4 spots to fill in. So, and the way it was shown on that last slide, right, is it's got like y's over x's kind of thing. Now, it gives us one of the relationships between y's and x's right here. If x equals 2 and y equals 3, find y when x equals 1. Well, it told us the y value was 3 when the x was 2. So again, you see how I'm putting the y value in the numerator and the x value in the denominator. Well, it's going to work the same way with this next one. It's just it only gave us the x value, which is 1. We need to find that y value in this proportion. Now, there's several different ways we can solve a proportion. So this one, I'm going to show you guys, well, what the heck, we can do 3 different ways on this one. It's pretty quick, actually. Now, the first method that most people choose is cross multiplication, right, where they say, we're going to multiply these two across, which would be 3 times 1, and it equals the other two multiplied across, which is 2 times y. And we know 3 times 1 is 3. Now this equals 2y, and so to solve it, we'd divide both sides by 2, which would then give us this y equals 3 halves. And that's pretty good, but let's look at a different method even. All right, so that's cross multiplication, but the next method I would show here is, I'll do fish method next. So fish method is where we actually draw a fish, and no, it's not anything fancy, you guys. Sorry if that disappoints you. But the first thing I'm going to draw on the fish is the tail, which is just a straight up and down line. Now, I always start with the unknown, which in this case is the y. And you either have to go up or down from the unknown. And it could have been over here. It's just not in this case. So I'm not going to put it there. But you go down like this. And the way this sets up for fish method is you got 4 different values in the entire proportion. And it's always multiply, divide, and equals. And hopefully you guys can see the relationship between fish method and also cross multiplication by the time I finish this, because they're pretty much the same. So I go down from y to get to 1, and that's the first number I encounter. Now I'm going to cross up here to the 3, and some of you guys already see, I can see how the fish is forming. I swing it back down around to the 2, and that's the third number I encounter, and then finally I end where I start, which is, it should always be the letter, okay? So just operating on this one, right, 1 times 3 is 3, 3 divided by 2, again, it would give you 3 halves right here. So that's the second method. The third method is just scale factors, which generally work out really well. They work out very well in a problem like this one. So on this, what I would say is I would evaluate these numbers first with, this is scale factors, you guys. So we're just scaling the numbers, right? It goes back to that whole manipulation thing. What is it that I want? And I need to force the numbers to do what I want them to do, essentially imposing my will on the numbers, right? And it should hopefully give you guys a great deal of control and confidence in using these properties. But these two fractions are equivalent, right? And I see a relationship between 1 and 2 on this. I don't always find a relationship, which is why cross multiplication or fish method is actually a little bit more practical in some cases. But I see with 1 and 2, I would say, well, what do I got to do to 1 to get to 2? And some of you guys know you just multiply it by 2, right? Well, maybe I'm going in the wrong direction because my unknown is on the right. So yeah, let me take that back. Maybe this way would work, right? I'd say, how do I get from 2 to 1? Well, I'd divide 2 by itself to get 1. I mean, that's hopefully it's pretty obvious. But remember, if we're scaling it like this, then we've got to do it to the numerator if we're going to do something to the denominator, right? So where I divided by 2 in the denominator, I'd have to divide by 2 in the numerator as well, and we see how that would give us also 3/2. Now that's a sideways comparison. It is possible to use an up and down and, well, yeah, up or down comparison as well. It doesn't really work with this one just because it's fractional, or it would give us a decimal value. But yeah, that's 3 different methods to solve proportions. And again, whichever way you like, just ignore those other ways. So there's a word problem. That's nice. The weekly pay that Melissa receives varies directly with the number of hours she works. So again, that, like we would assume, the more she works, the more money she get paid, right? If she works 21 hours, she makes $259.56. How much money would she make if she works 35 hours? So this brings up a new proportion for us, right? So I set it up, 2 fraction lines that are equal. I do want to see a separate fraction like this, and this just helps me to maintain where the labels are going to go, because it is a word problem. And so we have to consider what 2 quantities we're comparing. And we can see over here it's between hours and then dollars, right? Now it doesn't matter where we put either one of the labels in the numerator or denominator. We really get to choose on this one. So you could choose either way, but I'm going to put the dollars in the numerator, and we'll put the hours in the denominator, okay? So already, just right away, I can start labeling the numerators and denominators, which hopefully is going to help us to know if we've misplaced one of the 2 values, all right, between the 2 relationships that it gave us, such as 21 hours for $259. There's one of the relationships. So I can enter that into one of the fractions, and it doesn't matter if it's on the left or right, okay, because we're always talking about equivalence when it comes to proportions, which is why the order doesn't really matter on this stuff. So I got $259.56 for 21 hours. Now, some of you guys would be like, well, I just want to figure out how much Melissa would make per hour, and then you could go from there, which is true. And if you want to do it that way, that's fine. I'm going to proceed with just solving it with the proportion, though. And the next relationship says, well, it's 35 hours, right? And we don't know how much money she's going to make for that 35 hours, so you could use X right there. Now, like I said, though, if you had misplaced, maybe for some reason you thought that the 35 here was the dollars and you misplaced it here, hopefully by reading or rereading this problem a few times, you'd see, I misplaced that, especially by having the label there already. Okay, so if we keep this organized and we reread it for accuracy, then we're less likely to make the mistake of misplacing these, which is it would cause huge problems as we solve it. So again, most students prefer cross multiplication. I really like fish method, but here we go with cross multiplication, all right? So I got that $259.56 times 35, and it's going to equal the other cross multiplied, which is 21 times x. I got to go to my calculator. I know it's not showing today. I should have it by next time, I hope. So 259.56 times 35, I'm just typing it in. It shows 9,084.60 equals 21x. All right? So yeah, we're just at a one-step equation now where we can just divide both sides by 21. So 9,084.60 divided by 21, what does that give us? $432.60. That would be equal to 1x. And we know x was just a placeholder for this part of the proportion. So make sure you label the answer. We don't really need to circle the x in this. And well, I guess the last thing I should do is just check my answer, right? So if I do 259.56 over 21, the decimal in my calculator shows 1236. Now that's her hourly rate. That's the unit rate for Melissa. But if I do 432.60 divided by, what was it, 35? Yeah, it still gives me 1236. So it shows that her hourly rate, or her unit rate for this one, is the same for both, which is what we need in order to maintain the equality part of this, which is what a proportion should do, because it's showing that the two fractions are equal right here. Okay? Variations then. Again, this is just indicating that as one value goes up, the other should go down. Whether it's x or y, it doesn't really matter, you guys. Now there is a little bit of, I guess, some formulas that go along with it. I take that back. You probably will have to memorize those for the test. But in any case, inverse variations, it's not that bad. It really, there's only one formula that you would have to memorize if you did. It's just this k business right here, okay? K is equal to the two values that they give us, x or y. Just multiply those two together. Then you get this. It's the constant of inverse variation. What do they call it? The constant of indirect variation. It's the same thing. So it has lots of names, which is how or why many people think that us math people are really smart, because we change the names of things as soon as you get it figured out. So inverse variation, k equals x over y. Now, this right here, this y equals k over x, it's just an equation manipulation thing, right? So we've used the principle of equality on this formula right here, where all we did was we said, you know what, I'm going to divide both sides by x, and then I end up with 1y, right, which is what that is. Okay, so these two formulas are the same, they just look different, right? And again, that's about taking control and power of the math to be what you want it to be, or what it is that you need it to be. Okay. Yeah, I think this example hopefully will clarify what I was talking about. Now again, I'm not showing the formula right here. We'll still look at it because we're going to need it though. But let me read this, which will hopefully help us to know what we need to do. Y varies inversely, and yeah, I think you can expect that type of language in the homework as well. Y varies inversely as x, which sounds super weird. But if x equals 8, then y equals 6. Find y when x equals 2, and find the constant of variation, which we'll do. Round the answer to the nearest hundredth, I guess we need to. So let's do that. Well, we're going to need the constant of variation first anyways, all right? So that's k, right? And remember, for an inverse variation like this, it's just x times y. Now, we do have corresponding x and y values up here. X is 8, then y is 6. So I'm going to replace these two values that we have. The x, right, I said it was 6, and then the y value is 8. So there's 8 right there. And when I multiply these together, I get 48. Okay. So that's my inverse proportional constant. Again, however you want to say that right there. Which will then help us to figure out this missing y value right here. Now, going back to that last slide, we know that y equals k divided by x. And we will investigate more in terms of manipulating equations, because it's not really a skill that we've gone over explicitly yet. But it is a very crucial skill nonetheless, and it gives us more power to take control of the numbers here. So right here it says that x is 2, right? I'm going to use a different color. X is 2. So I'm going to replace the x in this formula here with 2. And we already know the k value, that inverse proportional constant, 48. So if I'm solving for y, I'd do 48 divided by 2, which should be 24. Now before, when x was 8, y was 6. And we've increased x to be, we decreased x to be 2, which means the y had to increase essentially what we would say is proportionally, you guys. So even though it's an inverse proportionality here, we lowered the value of x from 8 to 2, which means that we increased the value of y from, 6 to 24. And another thing you could consider on this, the x relationship was 8 to 2, right? We went from 8 to 2. Well, what would you have to do to 8 to make it 2? You'd have to divide it by 4, right? To get 2. So if we looked at y the same way, we started y at 6, but instead of divide by 4, because that would be a direct variation, you would have to inverse the operation and multiply it by 4 to get 24. So it gives us the same answer either way. And maybe that division multiplication thing is a little bit more clear for some of you guys, because it means that we wouldn't need a proportional constant if we analyzed it that way. It's just that on the homework it's going to ask for that constant of indirect variation. Up there when it says find y when x equals 2, that's the 24 right there. That's the y value. So y equals 24 24 when, x is 2, and x equals 2. And so there's one answer, there's the other answer. This one right here, man. Oh, I worry about this problem. I just don't like the way it's worded. I actually don't like the way it sets up either. But let's read it and I'll explain, okay? The loudness L, so they've defined L for us, which was nice, of a sound measured in decibels, dB, is inversely proportional to the square of the distance, d, from the source of the sound. Now, they should give us these two formulas on the homework. I've never seen a question like this on the test, you guys. So if you guys were like, dude,
they don't give you the formulas.
But in any case, these are the formulas for the inverse proportional relationship, where the square of the distance. I don't even know how to word that myself, okay? But we're going to use these to figure this out. Now, what it's saying though is that if you're next to something that's loud, the farther you get away from it, the less loud you get. The thing will get. So if you're standing right next to a speaker at a rock concert, it's going to be a lot louder than if you're in the nosebleeds, and it's the same level of loudness, which would make sense. Okay, and that again shows us that it would be an inverse relationship. So the rest of this says a person 11 feet from a jet ski, it shows it's 92 decibels loud. How loud is the jet ski when the person is 53 feet away? And we'll round our answer to the nearest hundredth. That's okay. But like it's showing here, you're 11 feet away and then you're 53 feet away. So we would expect the amount of sound to go down. All right. Now the problem is that we can't really use the same type of method we did on that last problem, where it was, what's the relationship between 11 and 53, because it's a square relationship on this one. So the first thing, again, I would recommend doing is just finding your inverse proportional constant on this one, which it shows is, it should be, there we go. So yeah, we're going to, that's a 2 right there. All right, so, what values did they give us up here? Specifically, what values gave us a good relationship on this? Well, we know 11 feet produces 92 decibels. Okay, so I'm going to replace the L. Should be able to replace the L. Well, I will. A second then. There we go. I'll replace the L with the loudness he gave us, which was 92 decibels. Okay. And then next up, we'll replace the D, which is the distance, in feet, which is nice, with 11 feet there. Okay. 11 feet. Now I'm going to calculate this with, of course, my calculator. And this is going to tell me the value of K in this problem. Let me go ahead and type that in. So K equals, let's figure it out. Now this is just the inverse proportional constant. So I don't need to label this. It's just, now there is a point where we'll need, I think, to square root something. No, looks like we won't actually, which is pretty nice actually. It's pretty good. So we have the K value, which we do need. But next up it says, we want to figure out the loudness. Yeah, we need the loudness though of the jet ski for someone that's 53 feet away. So I'll set this up right. We know that it just based on what tells us up there. The loudness is the inverse proportional constant divided by the distance to the power of 2. So we just figured out the K value right there at 11,132. And we know the new distance though, which is 53. Look, if you put 11 in there, it would just kick out the previous loudness, which would have been 92. So make sure you're using the right distance on this one, which for us in this case right now is 53 feet. Okay, so I'm typing this in, 11,132 divided by 53 to the power of 2. And this gives me a loudness of 3.962. So I'm just going to show it, because it did say it around the nearest hundredth. 3.962. And again, this is now labeled in decibels right there. Be careful on this. The setup is pretty clear on this if we use those two formulas. And they're pretty crucial on a problem like this, because when it talks about the square of the distance and stuff like that, it can really throw us off. But hopefully that helps you guys when you see this problem in the homework, that you can do it with at least a decent amount of confidence. All right, this is the percent proportion. You'll have at least two of these three pieces of information. Yeah, we have to, because the 100 will always be given to us if you're going to use the percent proportion. Now, I don't use the I use the percent proportion so much that I don't necessarily use the percent equation. If you like the percent equation, you're welcome to use it though. So it's when you take the percent, and you'd have to change that into a decimal. You'd multiply that by whatever whole value it is. And of course, percent of a whole is like, well, it's part of a whole. It's only a piece of the whole, which is why it equals the part. Okay? So this would be the percent equation down there at the bottom. Like I said, I'm going to be using the percent proportion, especially since we've been dealing a lot with proportions. Well, not a lot, but at least a little bit in this lesson. Yeah, of course. So the last thing I forgot on this is, and I do apologize, the part is, when you're looking at these specific types of problems, it's the is number. And we'll see that here in a second. But the whole is the of number, and we may see that one. But when these are worded, it'll be like, what percent, what is 35% of some number? And then you know, since they used of, that it's the whole. Or if they say something like, I don't know, what is, well, no, I'm trying to think of how that's even worded. 76 is 45% of what number? Well, then they told us the is number, and then we would know to replace that with the part. And it works the same in the percent equation as well down here. So again, you get to choose which one you want to use. And it should help us to solve problems like this one. Round answers to one decimal place is needed. What is 35% of 72? So again, I start by setting up my percent proportion, which means that 100, I just always put it right there. Now, if you put the 100 on the right side, it's not going to matter, as long as the percent goes directly above it. All right, and it does give me a percent right here. I do not need to change it into a decimal. The proportion is going to do that for me eventually anyways. And so yeah, back to this one then. So there's our key word there, is that of business. Since it's of 72, I know it goes in the denominator, all right? And so I'm going to have to find the part on this one, which is automatically the numerator, as long as we're using the percent proportion. Now you can use whatever method you want at this point. I'll do this one with cross multiplication, even though I may use fish method in this section. But yeah, we're going to do 35 times 72 for the first cross, which is going to give us 2,520, and it should equal 100 times x. So we got 100 times x right there, and to solve this, of course, we just divide both sides by 100. And dividing by 100 is nice, that gives us 1x, which is what we want. But on a regular number, I'd just say move the decimal 2 times to the left to make this 25.2. You could type it in the calculator, it's still going to give you the same answer. So this means that 25.5 is 35% of 72. So, and that's where the percent equation comes in. It's just, I find that a lot of students, not a lot, but some students seem to make mistakes with the percent equation as opposed to the percent proportion. Yeah, I fixed that. It's 25.2 now. All right, so here we go. 16.1 is what percent of 70? So yeah, I'm going to go straight to the percent proportion on this one. Where 100, I always just put it there in the bottom left. And we didn't get the percent on this one. It even asked what is the percent. So hopefully we know that that's where the x goes. Next up, it did say that it's of 70. And again, since it said of, I know it goes in the denominator there. And then it even has 16.1 is, which means it has to be the part on this. Okay. So I used cross multiplication on that last one. I don't think this one really lends itself very well to scale factors. So yeah, I'm going to go straight into fish method on this one. Which again, it's not required that you use it. It's just a decent technique, I think. So again, I would start at the unknown, which in this case is x here, and I would go down. So the first number I encounter is 100. I would cross up to the 16.1, swing it back down to the 70, and then finish off at x, which is our unknown. So this one I will need to put it into the calculator. 100 times 16.1 divided by 70, bam. Oh, it came out as a whole number. I did not expect that. So 23 is x. So now this one, it was a percent though, right? So it's not just 23, it's 23%. So yeah, just make sure you label the ones that are percentages. Or yeah, I guess they'd probably be labeled in the homework, but if it was on paper, make sure you label those. I know that doesn't really answer your question. I think that was Emily, right? So I do apologize. Again, I would just say, yeah, whatever's easiest for you, that's the way I would do it. Is there any other questions, you guys, right now? Let me see what the next one is. But yeah, 27.3% of what number is 64.789. So yeah, we'll use cross multiplication on this, and still percent proportion though. Okay, so I got percent over 100, and this one did give us the percent at 27.3%. Okay, now it's where this 64.789 goes in the next fraction that will be crucial in order to obtain the correct answer. And since it is 64.789, not of, again, if it was of before that, it would be completely different. But it is 64.789. Since it's the part, you guys. So that's the 64.789 right there in the part position of the percent proportion. So the part we're looking for in this one, not the part, the missing piece in this is, in the percent proportion, is the whole value there. So we'll go ahead and solve this, and yeah, just as promised, we'll use cross multiplication. So the first cross for me shows 27.3x, and then this is 64.789 times 100. Again, I would just move the decimal 2 times to the right to make that 6,478.9. And then finally, to solve this problem, and now I'll need my calculator, I'll divide both sides by 27.3. And that'll tell me what x is, which is the whole value. So 6478.9 divided by 27.3. Oh yeah, it's a pretty ugly decimal. It did give me 237 point. Where did it say it? Around 1 decimal place. So I have 3 2, so I'll just keep it as 3 right there, and that would be the whole. So again, this would read, now that we know what the number is, 27.3% of 237.3 is 64.789. So the percent equation, right? That would be where we take the percent and we multiply it by the whole. And I usually put the whole in red, not that it matters. And then that would equal the part. So on this one, we know the percent again. So I'm going to replace that. Just in the percent equation, you do have to change the percent into the decimal value. So again, that's just a matter of moving the decimal 2 times to the left, which would make that 0.273. All right, and then we know the whole is the value that we're missing because, just like we discussed before, the part is the value that was given to us as 64.789. So in the equation, I got 64.789 right there, and it's the whole that we're solving for. So again, instead of the word whole, I'm going to use X right there. So in this case, to solve for X, all we would need to do at this point is divide both sides by 0.273. Divide by 0.273. And I believe it should give us the same answer. I just want to do it in the calculator to check. 64.789 divided by 0.273. Yeah, I did. So it gave us the exact same answer there. Your bill comes to $30 and you will leave an 18% tip. How much will you pay total? Well, there's a couple ways to do this, you guys. And the most common way, or at least at first, is where we actually figure out how much of a tip we would want to leave, right? And yeah, the percent proportion would lend itself to this. And I know not everyone needs it. But since we've been using it, I'm going to use the percent proportion, all right? And it gave us 18% right there. That's the amount of the tip. And the bill came to $30. Now that's all of the bill. The tip is only going to be a part of that. So I know the bill itself is $30 total, and I just need to figure out part of it, which is now the X. So to solve this one, of course, just cross multiplication. So 100 times X, and then 18 times 30, 540. And then finally just divide both sides by 100. And that'll tell us the unknown value there. So that's 5.4 right there. It's a decent tip, You could leave more, that'd be good. So right now, that's just the tip, though. It really asks for the total. So what we got to do is we got to take that $30 and add it. That's a 0 right there. We got to add it to the 540, which is going to make that $35.40. That's not too hard to calculate. Since it was just straight $30. But yeah, that would be the final answer on this one. There are other methods to use that we could use to solve these. But I kind of want to stick with this for now. Tracy paid $175 for an item that was originally priced at $390. What percent of the original price did Tracy pay? Okay, so again, we've encountered a percent proportion. We want to know the percent of something that it was. So I got 100 right there. Now, it was originally priced. Again, that would be full price right there. Maybe I should use red. Full price would be $390. So that's the whole price. And this shows the correlation between the 100 and this bottom number right there, right? $390 would have been 100% of the price. But instead of paying the $390, what we did is Tracy paid $175, which is only part of the original or full price. So once we solve this, we'll know what percent that is. Now, you got to be careful because if I remember right on the homework, it'll be like, what percent off was it? So you got to be careful. Again, that may take reading this a couple times, but if you keep putting in the answer, it's like, it seems like I have this right, but it's it's giving it to me wrong. You may have to go back and read it because it says what percent of the original price for this one. So we're set up pretty well on this one. Okay. So again, cross multiplication, fish method, it's not going to matter. I'll stick with cross multiplication just for consistency purposes. So I'll start with 390 times x. It doesn't really matter which side you put that on. Then 100 times 175 is 17,500. And then just divide both sides by 390. See how that's fish method? We multiplied, then divided. It still gives us the same answer. But I need my calculator for this one. 17.5 divided by 390. And it's going to give me a pretty ugly decimal. What percent? I'll round this to the nearest tenth. I have 44.87. I'm just going to make it 44.9%. Now, again, that's the percent of the original price, which is true. Okay, but if it was like it wanted the percent off, you'd have to subtract that out of a 100, and that would tell you how much off they got. I mean, what the heck is that? 55.1% off? The first chapter of a certain book, if the first chapter of a certain book is 22 pages long and makes up 2% of the book, how many pages does the entire book have? Well, this is a pretty good percent proportion. I like this one. So we got 100, and there's our percent proportion. They did give us the percent there at 2%. Now, again, it's just a matter of where does this 22 go? Well, 22 pages is that 2%, right? So again, I'm just referring back to this. Hopefully that helps us to know that they should go across from each other this way, or that the 22 pages is only part of the book. So we know that the 22 should be the numerator of that second fraction. All right, and what we need is the denominator of that fraction. So, if this one, you could see maybe the scale factors works a little bit better on this one. So, 2 times 11 is going to be 22. So just take 100 and multiply that by 11 to get that answer, 1,100 pages. So I know I solved that a little bit differently. It's only because the opportunity arose where the scale factors were, it seemed like it was pretty obvious to me right there, but it may not have been as obvious to you, which is okay. And if you use cross multiplication or fish method, it would still give you the same answer.